Well, hello guys. Today's the 181 day of me doing Codeforces every day until I reach expert. And let's just dig in. There isn't anything more to say about it, right? Yesterday I tried the 1600 problem and it's kinda pretty difficult. So I will go back to the 1500 range because 1600 is too much for me, so let's go back to the 1500 range. Let's see. Ruler. Not really many people have solved it, but let's try. I hope that I can solve it by myself. I hate those fucking flush. I ain't gonna do it. I hate those flush. I know that maybe sometime in the near future I will meet it again, but I don't really like it, so there's no reason for me to fucking do it, right? Maybe this one, 9,000 people have solved it. Not really much, so yeah, but whatever. Let's read the test cases. Consider a game with n cards and is even. Each card has a number written on it between 1 and n, okay? So it's like a permutation, right? A permutation. All numbers are different. We say that the card with number X is stronger than a card with number Y if X is okay. Alex and Boris play this game. Each of them receive half of the cards, and each card belongs to exactly one player. Boris, Alex goes first. Okay. On a player's turn, he must play exactly one of his cards. So, and the game ends. Okay. If the opponent doesn't have any card stronger than the card played, the game left in a draw. Okay. The number of ways to distribute the fuck so that Alex wins, the number of ways to distribute the card so that Boris wins, and the number of ways to distribute the card so that the game ends in a draw. Oh, wow, this is kind of pretty hard, right? Well, I don't know, maybe backtrack or something. I don't know. I think backtrack. You may assume that both players play optimally. If a player can win no matter how his opponent plays, he wins. Oh, okay. Okay. And is 4, Alex receives the card 2, 3, and Boris 1, 4. Well, I understand that if you receive the biggest card, then of course you will win, right? Because if there isn't any bigger card, then the other player wins, so. Oh, okay, you can start new turns, okay? Understand. If Alex plays a card 2, okay, so the game ends in a draw. Okay, understandable. Okay, there are 60 ends, right? So not really big. But it's a backtrack problem, so I'm kind of worried because it's backtrack. It's super large and I don't even do much backtracking, but let's try to think of a way to solve this problem. I mean, I'm not really confident about this problem, but what can we actually do? Oh, modulo. We must modulo it. Okay. And one. Alex. Boris will be 0 and draw will be 0. Okay. In the first case, if he received... Okay, let me open the whiteboard real quick. There are only 60 ends, right? So I don't really believe that we can get time limit exceeded in here. I mean, if we don't do it optimally, maybe we can still get time limit exceeded, but I don't believe that because n is super small, only 60, right? So maybe we can still maybe brute force it or backtrack in not the most optimal way. I'm not sure. That's just my presumption. But let's see. 2, 1 and 2, right? There are only two ways to deal the cards. This or this, right? So it's either Boris win or Alex wins. Oh, okay. Alex goes first. I forgot about it. Alex goes first, right? Alex goes first. Alex goes first. So is backtrack even possible? I'm not sure, but I don't want to guess, but is backtrack even possible? Let me think about this one. I'm not thinking that you must use any advanced algorithm here because we just need to optimize it somehow or think about a solution about it. Wait for me a minute. I will get out of it. Okay. Shit, my legs are fucking in pain. I've trained legs for 2 days ago, but it's still fucking pain now. I don't know. It's yeah, painful as fuck, but whatever. 60 is the maximum number. Second test case 4. 6, right? If n is 2, then there are 2 possibilities. If n is 4, then there are 6 activities. 20. So is there a formula for this one? Is there a formula? Because this looks fucking too big for me. How much is this? 70, right? Yeah, it's 70. Come on, there must be a formula for this. Because it's just fucking so huge, right? 4 to 6. 4 to 6. Is there really a formula for this? We also have to modulo it, so the answer is pretty huge. So I don't think that we can actually. Oh, as you guys can see, there are always only one way for it to be a draw, right? Come on, look at this. Look at this. There's only one way in order to get a draw. So let's just write 1 here. Okay. So I have no logic why there's only one way to get a draw, but look at the test cases. There only one time that it's gonna be draw, so I don't think that I'm not correct. So whatever. Let's see. Uh, this is disturbing as fuck. This is disturbing. Shit. Let me think about it. Backtrack or something? I don't know. But let me get a drink and think about it. Wait for me fucking 10 seconds. Let's guess. Shit. Actually, no fucking way. Mm, it's only a permutation, right? So it's either you win or I win, right? It's either you win or I win. So it's either you win or I win, right? For example, 4. 1, 2, 3, 4. If it's 1, 3, 2, 4, then it's basically Boris wins. There's no other explanation, right? But if it's 1, 4, and 2, 3, 1, 4, and 2, 3, like this, you place a 1 here. Boris turn start. 1 here, 2 here. Okay. 4. There are 6 possible ways. Let me try to figure those out. 1, 2, 3, 4. Okay, so Alex wins for sure. How about 3, 4, 1, 2? Boris wins, right? Boris definitely wins with this one. Boris wins. What about 1, 3, 2, 4? 1, 2, 3, 4. Boris wins. How about 2, 4, 1, 3 here? Alex wins, right? But there one more case. What is that case? It's 2, 3, 1, 4. Yeah, 2, 3, 1, 4. 2, 3, 1, 4. 2, 3, and 1, 4, 1, 2, 3. If Alex plays a card 3, Boris 4. Boris all. So the game ends in draw. So draw. Place here. How about 1, 4, 2, 3? What about this one? Alex plays 1. Boris 2. Alex 4. The game ends. Most optimally. Let me think about this problem. It's kind of disturbing for me, right? Because if it's One, four, two, three. How do you gonna place his number? On a player's turn, he must play exactly one of his cards. Oh, only one card. Okay. Okay. Okay, now I understand it. My bad, my bad, my bad, my bad. I read the problem not correctly, not really, okay. So we now know the problem, okay? Four. There are four cards. There are four cards. Four cards. One, two, three, four. Right? How do we switch this? How do we calculate this? Backtrack? I don't think so. I don't think backtrack will do anything here. 60, right? Let me try to calculate the complexity of my backtrack. That's just assumption, but I hope not so. Yeah, 2e is 60. That will be 10 power. No, that's not possible. That's not possible. Đi chơi ạ, có đi chơi ạ. What card? Alex is always winning. Alex is always winning. Backtrack is possibly not correct, but I think it's like a formula for mathematics. It has nothing to do with algorithm, right? It has nothing to do with algorithm. One four here. Two will come here. Four. It's a draw, right? It's in the draw. Okay. This is a draw. How about 1-4? 1, 2, and 3. Boom. 4, 2, 4, 2. And take turns. Alex go first. He must. Let's play the soccer. The game ends. The game ends. Hmm. Okay, now I understand it. Maybe, maybe not. So, if a player have a 4, I have a biggest number, then the game ends. Is that true? I don't know. Is that true? Because it makes no sense for me. If the opponent doesn't have any card stronger than the card played, the opponent loses and the game ends. The whole game ends, right? Not the turn, right? So if you get the biggest number, then you will always win. Is that correct? I think so. I'm not sure about my logic because it seems so dumb, but maybe that's the problem. Let's try to figure it out. Let's try to figure it out. Okay. Oh, they're removed from the card and the turn ends. Okay. There will be no point counting. Okay. Understand. I understand. Okay. Um, whoever get a 4 will win. Okay. That's easy to understand. Whoever gets a 4 wins. 4. Mhm. Where's my calculator? Okay. Mhm. The only thing that matters is the last card, right? 4 is the only thing that matters. 4 is the only thing that matters. There will be 3 ways to put it in here. 3 ways. Okay, and there are only so 3 ways in order to put it here. So there will be 6, and so how about 6? How about the number 6? 6 will be put here, right? So there are 2 more ways here. Oh, this is just pure mathematics. Am I correct? Is it pure mathematics? Yeah, it must be pure mathematics, right? Yeah, it's just a mathematics formula, I think so. 2 spots. We have 2 spots here. Hmm. 6 ways. We have 5 ways, and we have 4 ways. 20. That should be 20, right? Hmm. Okay, this is just a mathematics formula. I think so. I think this is just a mathematics formula. Okay, this is just pure mathematics, right? Yeah, this is just pure mathematics, right? Yeah, I think so. 20, 20 divided by 2 because we don't want it to be. Okay, this is just mathematics. I'm pretty sure. Yes, sir. 8. 3 spots left. 3 spots left. 7, 6, 5. 70. Ooh, okay. Okay, I think I got the formula for this one. I think I got the formula for this. 6, 6, 5 divided by 3, right? Because there are 3 numbers here. 70. 70 ways, right? It's 70 ways. 6 will be 5, 3, 2 divided. 20. 20, it will be 20. Four, 6. Shit, this is really shitty. I must think about this more. 6 here. 2 spots. 5 more numbers. 5 numbers. 20. 10. Oh, it's C, right? How about 8? 35. 35. 35. Okay. 7C3 will be 35. Yeah, this is the formula, right? This is the formula. This must be the formula. Yeah. Okay, we got the formula now, but we still got to know the way to distribute our formula. Okay, we got the ways, but how do we distribute it? How do we distribute it? Both 10 ways, right? How do we know it? How do we distribute it? How do we distribute it? Six. How do we distribute it? 6 here. Can it be a draw? If they have a 5, then it's a draw, right? Yeah, if there is a 5, then it's a draw. One, two, three, four, five, six. Don't have a 5. If they don't have a 5, this is just pure mathematics, right? If you don't have a 5, then blame on you. If you don't have a 5, then you're dead. Okay? Alex. Six here. Okay, let me think about this one. I think it's just mathematics. Let me think about it real quick. Shit. Well, only 9,000 people have solved it, so it might be a bit hard, but we still need to try to do it, right? 8, 4, shit. shit, 4. If there's a 3 here, then it's a fucking draw, right? If we got a 2 here, then it's a fucking win. 3, 4, right? 2, game ends. Nah, this can be true. 3, 4, 2, 1. This is a draw. Yeah, this is a draw. If Boris ever wants to win, 2, it's a draw. You lose it from a draw. How about 4 numbers? Shit. This is just mathematics. I know that for sure, but 4 here. How can you fucking lose it, right? Oh no. 6, my bad. 6. It should be 6, right? How the fuck could you lose by your own ground? The only way that he can lose is he has a 5 here, right? Okay, and if he got a 4 here, 6, 5 goes, 6 goes, okay? He also must have a 4 here, and he got a 3 here, right? There's a formula for this, but I haven't figured out. So now I have to figure it out. What is the formula for this? 6, 5. Turn. Opponent's turn, okay? 5, 6, okay. You must have a number bigger than 5. I understand that. Or else you'll lose. Alex always wins. Nearly always wins. due to this reason. 6. We have 2 slots left. Okay, 6-5. If we want Alex to win. How about if he has a 4 here, then you're cooked, right? 6-5. Draw. 4. Then this guy is cooked, right? If there's a 4 here, then Boris is cooked. 4. Okay. $45. Not to get cooked. Three ways. 3 ways here. 6. Who's to win? No, he doesn't. 6. 6 here. You're dead. If there's a 6 here, you're dead. 5. Okay, that would be 6 here. Whatever this is. Six. 4 ways. There are 4 ways for him. 2 ways for him to choose. 2 ways for him to choose. 2 ways for him to choose. And it would be how many times? 4, 5. 5 C2. 5 C2. It will be 10 times. And if this is chosen, what happens now? It will be 4 C1. It's 4, right? But that's not correct. Okay. 4 ways. 4 ways to choose. Choose this number. Must not choose this number. If that's not true, what now? If he wins here. If he wins here, there are only 4 numbers. 4C2. Nah. 5 here, right? If he gets a 5 here, and now it's his turn. You better have a bigger number than him. Here, it should be here, right? Okay, I think maybe I got the formula for this. I think maybe yes, I have the formula for this. Let's test it on 8 here, okay? The number 8. Let's test it. Let's test it on 8. Here, you're Alex. You are 7C4. Okay, actually 8C4, right? Nah. 8, 7C4. 35. Already here. How about this one? How many do you have? How many do you have up your sleeve here? There are only 2 numbers left. No, there's only 4 numbers left. And here 3C1, 8C4, right? 3C2. It's 42, right? So we're missing 7. Boom, left. Here. How many ways do we have to donate? It's only 3. This is getting, it's fun, but it's getting a bit hectic. I know I'm kinda got the idea, but let me think about it. It's dead here, it's dead here. You're dead here. Okay, I understand that, you're dead here. The opponent wins here, right? You wins here, Boris. You wins here. You wins here for sure, Boris. But he wins here again. There are only 4 numbers left. There are only 4 numbers left. It will be 4 numbers. Plus 3. How about here? I think I kinda got it, but let me think for it for 1 more minute. There are 3 places here. There are 4 places here. 35, understand it. Okay? You're dead here. Now it's your turn. Now it's your turn. It's your turn, so... What if you get a big number here? How many will it be? What if you get a big number? It would be yeah. It would be 5C2. 5C2. You get 10 here. Right? How about here? What do you get? 3C2. You get 3 here. Right? How about this one? You get 1 here. 1 here. This is not enough. There's a flaw in my logic. Let me think about it. There's a flaw in my logic. Shit, there's a flaw in my logic. 8 here. 35, that's for sure. If he wins, you got a 35. You don't really already got the 35. How many ways do you have to win here? It's his turn, right? So, how many ways to win? 5c2. 2 ways. 10. There are 10 ways here. Right? How about here? 3 ways, here's 1 way. There's something missing here. There's something missing here. There's something missing here. Shit, this is currently not the best idea to fucking learn, but I hate this idea, man. Forty-five. Oh, it's his turn. Shit, this shit is hard. 20. 20. Yeah, it should be 30, 21, right? That's correct. 35. 35. If he wins. thinking about this one real quick. Dynamic programmer. DP. No idea. This is not good. Alex Woods.